Resistors behaviors in DC and find out the Ohm's law in practical test results. In my hand there is a 10k ohm resistor. Now I'm hooking up the power supply, the positive terminal and the negative terminal. Now I can see some reading from the multimeter, and this is a flat rechargeable battery, so I can use this one as a load of my circuit now. So I'll try how much current will pass through this resistor, connecting the flat battery across this digital multimeter. Now from the power supply I can see 1 volt, and from the digital multimeter I can see like 0.09 milliampere is passing through this resistor. Now you can see for 1 volt the data value on the multimeter is 0.09 milliampere. At the same time I have plotted the values on the graph paper. In this graph paper I have plotted the voltage in X direction and the current I have plotted in Y direction. If you watch carefully you can observe the changes of current with the changes of voltage. I'm increasing the voltage gradually from 1 volt to 20 volt. Just watch it. After zooming out this graph paper, we can see all this location of the coordinations on the graph paper, and it makes a straight line. In the x-axis the voltage and in the y-axis the current, and you can see all this value from 1 volt to 20 volt, and the current is from 0.09 milliampere to 1.96 milliampere, which we have found from the multimeter and from the power supply. All this value comes from the practical test, and we found this straight line, and this straight line from 0 volt to 20 volt, it means that the current I is proportional to the voltage V. Now it is clear that V is proportional to I, and it makes this straight line. Now I picked up a value from the graph paper like the last one, the 20 and 1.96 milliampere, and then I'm calculating like this, and I can find out the resistance like this, 20 divided by 1.96, and it is 10.2 kilo ohm. So this value is nearly to the manufacturer value, and we found that one from our practical test result.